math mode. So everybody pay attention now. Let's put some problems on the board. Let's go to our handy dandy assignments. Let's go to 4.3, isn't it?
Yeah.
And I'm going to go over these. I'll pick the problems that I like as far as homework problems. What the heck is this? Oh, that's the wrong class. Duh. It's okay.
Multiple choice word problems. If they would just give me a problem to work, I can make it.
I know.
I
know they are a little bit aggravating. That's why I try to tell us how you really feel. Oh, that's great. It's all recorded and everything, so everybody can complain.
At least you can say I did.
Oh, if I said it, oh my God. Okay. And some of these psychology and history and English teachers can say whatever they want. As soon as Hubert says something, oh my God. All right, that looks like a pretty good problem right there.
Good, I can do that.
Good. That's the problems I'll put on the test. So go ahead and write this one down and let's do it. And then I want to do a couple that doesn't look so pretty, and you have to manipulate them a little bit. And that's with multiplying by negative over a negative.
And one like 71 in the book is one that is I don't know, it seems hard to me.
71 in the book. I'll have to look for it.
4-3. Yeah, I got there. And the further I go in the problems, it's just. It's like,
all right, so this one is 8 over x squared minus 2x minus 1 over x squared minus 4. Now really, this is, go back to pre-algebra, 1 over 7x minus 3 over 2 x squared is equal to 0. No, that's not good to use. Let's do let's just do this. Let's just change this into 3. 5. These are the same type problems. Okay? You got to find a common denominator to multiply through by. Well, if the denominators have nothing in common, like 7 and 3, what do you multiply through by? Nope. 21. What do? You multiply them what? Together, and you multiply through. 7 times 3 times 1 over 7. 7 times 3 times 5 over 3 equals 0. And what happens? Here's the 7 cancels, here's the 3's cancel, and you're left with 3x minus 35 is equal to 0. So I went through and I cleared the fractions. The fractions have nothing in common, so therefore you just put them together. What do these two have in common? Nothing. So what do you multiply by? X squared minus 2x. You could factor out an x right here, yes. And you could factor x plus 2, x minus 2, and you could do it that way. You could do it that way. That's fine. But sometimes it's easy. Sometimes it's easier just to multiply through. Okay, let me get back to what I was doing. Hold on a minute. Okay. There. So you can factor out an x here, and let's change it to 8 over x times x minus 2 minus 1 over x plus 2 x minus 2. Now we can just go ahead and... These really have nothing in common except one thing, and what is that? The x minus 2. So I'm going to take my highlighter, and that's the only thing we have in common. Now, the x and the x plus 2 has nothing in common, so what are you going to do with it? Put it together. So your common denominator for all of this is going to be x times x plus 2, times what? X minus 2. So I took what's not in common and put them together, and then put it with what's in common. Now I want you to distribute all of that with a baby step, especially if you suck at this. Take a baby step and put it with each one of these and see what actually cancels out. Now, I realize that some of y'all don't like to write extra steps, but like I said, if you're not good at this, then you need to learn. And what happens on the right-hand side? You get 0 here, but thank you, class. And what happens here? What cancels? The x and the x minus 2 cancels, and that leaves you with 8 times what? X plus 2. What cancels here? And what's left? Minus x is equal to 0. And now you've got a free algebra problem. Finish it out. And what do we always need to do on these type problems? Check it. You have to, because you have a denominator and you can't have 0 in the denominator. So you get 8x plus 16 minus x is equal to 0. 8x minus x is 7x equals negative 16. So x is equal to negative 16 sevenths. Now when I say check, do you have to actually plug and chug and do the math? No. What's the only thing that's going to give you a 0 in that? A positive or negative 2. And then you have to solve the other one. X be x minus 2, positive and negative 2, and 0. Do we have a 0 or a positive and negative 2? No. So that will work. Your answer is negative 16 seconds. Now that's a test question. Negative 16 over 7. And we feel good about ourselves. There's another test question. Do that one. 1 minus 13 over x plus 40 over x squared is equal to 0. What number did you say yours was?
It's 71.
Okay.
And I looked at things like conjugates and all sorts of things. So I don't know exactly what I'm talking about.
Okay. Alright, so we have 1 over 1 minus 13 over x plus 40 over x squared is equal to 0. What is the common denominator of 1x and x squared? Always remember, when you're trying to find a common denominator, you go with the highest exponent. When you're factoring out something in common, you go with the lowest denominator. So the highest denominator is what? X squared. So I'm going to multiply through by x squared over 1. 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 1 over 1. 13. Oops. 13 over x. 40 over x squared. And 0. X squared over 1 is x squared. What happens here? This x cancels with one of these x's, and that leaves 13x. What happens here? Plus 40 is equal to, now you can use factoring if you want to use factoring, or I'm going to use least square. X squared minus 13x plus blank is equal to negative 40 plus blank. Half of 13 is 13 halves. 13 halves is 169/4. X minus 13 halves quantity squared is equal to negative 164 plus 169/4. So x minus 13 halves quantity squared is equal to 9/4. Vertex is 13 halves and negative 9/4. X minus 13 halves is equal to 3 over 2 minus be a plus 13 over 2. X is equal to 3 plus 13 is 16 halves, that's an 8. And negative 3 plus 13 is 10 over 2, which is what? We got two possible solutions. Plug in 8, plug in 5, zeros, good. There's your answers, 8 and 5. That's a good test question right there.
I think I see why you're giving us these problems. You're going to make us the thinking square experts by the end of the semester, right? That's your goal.
Yep. And you say there's 2 or 3 students in here that are going, well, I'm going to keep using quadratic formula. And you're going to suck in calculus 1.
Yep.
Mr. Harvell, tell them.
It's true.
The stronger algebra student you are in Calc 1, the better you're going to be successful in Calc 1. If you're one of these students that do everything opposite of what I'm telling you to do, you're going to fail. Mr. Harvell can attest to that.
Yes, it's hard if you don't, if this is not done, it's bad.
It's like 8 lines of algebra to 1 line of calculus. For every calculus problem you do in calculus, there's about 80% of the problem is algebra. The rest is calculus, which leaves 1 to 2 lines. And guess what you do not ever use in calculus? The quadratic formula. Because the quadratic formula, and people don't know this, when are you supposed to use the quadratic formula? With decimals. When you have, where's my, this is when you use the quadratic formula. Hold on a minute. (2.26) x squared plus 3.25 x minus 16.1 is equal to 0. That's when you use the quadratic formula. And when you see that, probably 1% of the time. But I can't believe you finally figured it out. I'm trying to make you do complete and square every time. You done figured me out.
Well, I mean, you've had us on it so long.
Well,
I can see you're going to make us do it to the end.
Yep. 5,8. Probably going to mark me wrong because I didn't put parentheses. Oh, wow. Good. That's the same type question. Ooh, should I make you do that one? Yep, I should. The reason I should is because you're going to see a lot of this in calculus. Negative what? Negative what? Negative exponents. You're going to see a lot of them. And what you do in calculus with negative exponents is get rid of them. I was in a meeting yesterday before we did stupid stuff, and 2 of the calculus teachers was fussing because they had calculus 1 students trying to do this. You see, they have negative 2x squared, and they would do this. And you can't do that. Okay? The only time you get rid of a negative exponent is taking it down. But you can't make a positive. If that was true, all of us would have what in our bank accounts? Lots of money. You can't make a negative $200 into a positive $200 by moving it. Okay? It's not possible. But you can do it with an exponent because the exponent is not a number. When I say number, like we count money, it's not a number. It's something that we use to multiply. So, you can't do this. But, when you deal with negative exponents, the first thing you do is remember the inverse rule. And I'm going to go over it again because I don't want you going into any calculus class with me as an algebra instructor, your algebra instructor, and you do that kind of crap that they just did. Inverse rule. The inverse rule of what? Exponents. I want everybody to highlight that word and put a circle around it, because I don't want you saying, well, you were taught me that I make -2 and a +2. No, I didn't. And the exponential rule of the inverse rule of exponentials say, if I have a negative exponent in the denominator, in the numerator, what can I do? Flip it, Hubert. That's right, class. Thank you. If I have a negative exponent in the denominator, what do I do? Flip it, Hubert. And that gives me a positive exponent. So, those x's, now let me ask you a question. Is that 100 to the negative exponent? No. Is that 399 to the negative exponent? No. What's the only thing that's to the negative exponent? So you can rewrite this as 100 over what? X to the 4th minus 399 over what? Minus 4 is equal to, now finish it. Multiply through by the common denominator, which is x to the 4th. What's things that irritate you on Facebook? You don't count. Did I ask you your most annoying commercial the other day? Did I ask you that?
Yeah.
Y'all didn't interact with me then, so I don't know why I'm expecting you to interact with me now. But yeah, but interaction goes both ways. With y'all, it's only one way. Okay, nobody has any input. Okay. What irritates you on Facebook? I don't think any of those. The thing that irritates me, and I'm a spiritual person, but why you got to preach on Facebook? That irritates me. It's not like you're going to convert anybody on Facebook, okay? You're not going to convert anybody. You're not going to dunk them under the water on Facebook, all right? To me, I don't think you have to advertise your wealth or your spirituality. To me, I think that answers itself. I used to know a man that used to live down in Star. His name was Bud Campbell. And that man, if you looked at him, you would think he didn't have a pot to pee in. Drove around a brown Cadillac, and he always wore a brown suit with a brown hat. He was one of those old grandpas who used to wear the hats with the big wide thing on it. That man was one of the richest men in Anderson County. And if you looked at him, you wouldn't think he had a pot to pee in. But he always, whenever he went to town, he'd drive that brown Cadillac. Thing sat under the garage. 90% of the time, he drove around a beat old pickup truck. Another guy lives in Liberty. His name was, But anyway, he owned the meat market right there on Liberty Highway, and where the Liberty Highway splits, and there's a meat market there. Can't think of his name. But he was blind in one eye, so he had this cataract-looking eye, and he always wore these beat-up old coveralls. And I know for sure he was one of the richest men in Liberty, South Carolina, but you never know it looking at it. So I just don't understand why you have to advertise your spirituality as well as your pocketbook. That's what gets on my nerves. Huh? What? Yeah. I think a lot of it has to do with attention. Huh? I watch it for the news and to express my political views. Yeah. That is so much like, and I'm sorry about this, females, but that's like y'all. Okay? When a guy says he's mad, he'll tell you about it. Nothing, it's fine. I don't want to talk about it. And what happens if you don't ask, guys? What happens if you don't ask what's wrong? You get it even worse.
You just busted me for telling him one time all about that.
What?
You just busted me for saying that was bullshit on there.
Yeah, but I have to keep the BS down because of the complaining people. You said you wasn't on Facebook. You can't talk about it.
I used to have.
Oh, okay.
It was when people were updating when the time used to happen.
Okay, all right.
Yeah, it's like, no, I'm serious. That used to be a big thing.
I don't remember that. But
A lot of people I knew on Facebook.
you have some strange friends. No, I'm just kidding.
Yeah, but it was like relatives. Distant relatives.
Oh, yeah. Minus 399 over x squared.
Oh,
You could bring the 4 over if you want to, but that's up to you. Minus 4 is equal to 0. Common denominator is x to the what? X to the 4th over 1. X to the 4th over 1. X to the 4th over 1. The 4th over 1. It's 399 over x squared. 100 over x to the 4th. And of course, the x to the 4th cancel, and that leaves you with 100. X squared will cancel with that and make that x squared. So 399 x squared minus what? 4x to the 4th equals 0. So now we got negative 4x to the 4th minus 399x squared plus 100 is equal to 0. And here we're going to say u is equal to x squared. Therefore, negative 4 u squared minus 399 u plus 100 is equal to 0. And you could try to factor that. I'm not going to. Negative 4, factor it out. Well, I'm going to move the 100 over. So that's going to be negative 4u squared minus 399u is equal to, or plus blank, is equal to negative 100 plus blank. And factor out the negative 4. That's going to leave you with u squared minus 399 over 4 u plus blank is equal to negative 100 plus negative 4 times blank, divided by 2, multiplied by 1/2, that's 399 over 8 squared, which is 64, which is 399. Somebody square 399 for me. $159,201. So negative 4, u squared, or u minus 3, let's see, square root of that is going to be 399. Yeah. 399 over 8. Quantity squared is equal to, well, 4 will go into 64 how many times? 16, so that'll be 16 right there. So I got to change this. 100 would be 1600 over 16. So 1600 over 16. This is a negative, right? I can't remember. Yes, it's a negative. Negative 592. 59201. Thank you. Over 16. That was 100. Okay, 159. And that's going to give you negative 4 u minus 399 over 8 quantity squared is equal to negative 1600 minus blah 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 is 150 or 16801. Somebody help me. Yeah. 16801. I'm just using third grade math up here. Over 16. Now we're going to have x-intercepts because you're dividing the negative by negative, so you're going to have a positive. So we're going to have x-intercepts. This is a dang good test question. That's going to give us, well, the vertex is 400 over 8. And some BA number, well, 16, let's say that's 160, so that'd be 10,000 or something like that. What would that come out to be? Okay, negative 10,050. That's your vertex. And then that's going to be, let's see, a negative times a negative, that'd be positive vertex. Positive. And that's going to be divide by 4 over 1, multiply by 1 over 4 will give me 64 on the right hand side. So that's going to be u minus 399 over 8 squared equals positive 16801 over, what did I say, 64? And then that's going to be u minus 399 over 8 is equal to the square root of 16801 over 8. And then u is equal to the square root of 16801 over 8 plus, that's positive or negative, plus 399. And somebody tell me, take your calculators, because we got two things. U is equal to, look, tell me what 16801 is. Square root of that. What is that? Good. 401 plus 399 over 8. And that's going to be U. Now this is important right here. And we're going to draw this in a box because it's important. U is equal to 400 plus 399 is, well, that's 800 over 8, which is 100. And U is equal to negative 401 plus 399 is going to be negative what, 3? Somebody help me out. Or 2. Negative 2 over 8, which is negative 1/4. Y'all check me. So we're not done yet. Why are we not done yet? Because u is equal to x squared, now we got to plug x squared in. So since u is equal to x squared is equal to 100, and x squared is equal to negative 1/4, and this will give us a positive or negative what? 10. What happens here? So there's your answers, positive or negative 10, unless they want the answers in terms of I. And in that case, that would be x is equal to I times the square root of 1/4, which would be 1 over 2. So 1 over 2i, they may want that answer. I don't know if they want that. 1 over 2, 1/2 I, positive or negative. I don't know if they want that or not. So let's see what they want. Negative 10 to positive 10 is probably what they want. Now, there's 3 types of students in this room. One is going, I got that, I'm good. The other one is going, I understand it, but I'm going to have to do that another time or two. And then there's the one that's saying, well, I don't know how to do it, I'm just going to skip it. If you can't do this problem, then you might as well just go ahead and change majors, because Calc 1, that's what you do in Calc 1. 80% of the problem is getting all this algebra down to this, and then boom, you do the calculus. Or you do the calculus, and then you have to simplify, 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 just like I did here. So if you're one of these people like, I just quit halfway through, then you're going to have a problem in calculus. Now don't raise your hand and say, you're talking about me. I don't know who I'm talking to. I'm telling you there's 3 types of students in this room. If you're with that last student, you're going to have a problem in calculus. Let's plug in positive and negative 2, or 10, whatever it is. Negative 10, comma, positive 10. They may want, yep, they're going to want the other ones too. So I'm going to put 1/2 I, but they may want positive or negative 1/2 y. I don't know. 1/2 I. They're probably going to want all 4 of them. Yeah, that's fine. I'm not. Yep. Why they got the opposite of what I got? I must have a sign wrong somewhere, because they've got the opposite. So they're saying that this is supposed to be negative 100, and this is supposed to be positive. So we need to check our sign. But the math is right. We got a sign wrong somewhere. Positive or negative? Positive. Yeah, there's something wrong, because I'm supposed to have a negative 100. So this needs to be negative 800. So that means I need to have a negative 399, which means this needs to be positive. There it is. When I pulled out that negative, I left that negative. There it is. I made a mistake right here. So you need to make a note. Right here. You see where I factored out this negative 4 right here? Everybody see that? That negative 4 should have made this a what? That's where I messed up. Sorry. That doesn't change the numbers. The numbers are the same. It's just the opposite. My bad. That's supposed to be a plus. That's supposed to be a plus. That's supposed to be a plus. Plus, plus, and then when you bring it over, it becomes what here? A negative, which means that's a negative, which means that's negative 800, and that's be a negative, so that'd be positive negative 10i, and then negative minus negative 401, or positive 401 minus 399 is what? 2. So that would be 2 over 4, or 2 over 8, or whatever it came out to be. I can't think right now. Oh, x squared is equal to 1/4, and positive or negative 1/2. There we go. Sorry about that, at least I found it. If I gave you one like this on the test, it would be just 1. I wouldn't give you 2 or 3. Okay. Yep, yeah. Or I could give you like 3 of these, and if you got them all wrong, you just failed. Well, actually, you'd have to get all 3 of them right, because if you got 2 of them wrong, you'd still fail. That's what I'll do. That way, everybody will fail. All right, let's move on. I want to move on to your question before I run out of time. Which number? Because I'm going up here.
It's 70. Well, this is their work, right?
Well, this right here, this 39 tells me what in the book it's like. So let me go to all. What's wrong with this thing? Hold on a minute. All objectives. 70 what?
71, yeah.
It'll be close to 73 then. Is that what it looks like? There was?
Yeah.
There we go. Is that it?
That's it.
Yeah. The first thing I would do is multiply by the conjugate.
Okay.
And if you do that, that's going to give you x cubed. It's going to give you x to the, let me just multiply both sides by the common denominator. Yeah, by the common denominator, not the conjugate. So, square root of 2x plus 3 over x cubed minus square root of 3. Multiply both sides by the common denominator of what? X cubed minus square root of 3. And that's going to give you 2x plus 3 is equal to 0, minus 3, minus 3. Square root of 2x is equal to negative 3. How do you undo the square root? Square both sides. Oops. 2x is equal to 9 divided by 2. X is 9/2. Huh? That's a good test question because it looks more complicated than it is.
I don't know why it's doing it.
Well, you did it because you saw the radical in the denominator. Now, how do you distinguish between this and the conjugate? If that was a conjugate, it would be an expression. It would not be a what? This is an equation. An expression would be square root of 2x plus 3 over x cubed minus square root of 3. And then I would say what? Not solve, but what? Simplify. That's an expression. And then you would use the conjugate because it doesn't have an equal sign.
Okay. Thanks.
That's a good test question. Yeah. Most people will quit and not even do it. So that's why I put it on the test. Yeah, exactly. Throw your pencil down. All right, now this is nine is greater than or equal to 1. Yeah, but I don't understand why they want you to put the solution set. There is no solution set. It's 9 is greater than or equal to 1, which is a true statement, which means all real numbers. So you put all real numbers. Let me see if that's what they want. Negative infinity to positive infinity. What? Of course. I don't care about the parentheses. I just want to see if that's what they want. -4 to infinity. Okay, I'm going to have to do it the way they want us to do it. Okay, let's do this one. Multiply through by common denominator. Trying to get there, y'all just hold on. Sometimes I get lost in what I'm doing. All right. Oh, I know why. Before we do this, let's see, so I don't have to go to the book. There is a part of the book, let me see if I can pull it up right here. It has a blue box, and that blue box has 3 things that you need to apply to your inequalities. Did I not hit text? Okay. Is this, which problem are we doing? I don't know why it went back to this problem. 67?
Yeah.
Okay. Let me try this again. Text. Okay, whatever. What page?
You talking about the chart?
Yeah, the inequality. Yeah, the 3 tests. There's 3 tests with the inequality.
2 and 2.
Thank you. You need to write this down for inequalities. And plus, you should already know this from your 102 class. Okay, it's not letting me. I tried to hit an arrow. Not supposed to have to. You could just hit. Okay, whatever. 290 what?
2. Next page is the first couple of pages. Yeah, there it is.
No, that's not the one I'm looking for. Oh, wait a minute. No, that's not it. Let me find it right quick. It's a box that shows you the union and the intersection.
Union and intersection.
Yeah, it should be in that. Should be like a blue box, and it should show you the when you got both of the inequalities going one way and both the inequalities going the other way.
You see they have any of those things.
Okay.
You should say, because right there, is kind of done by using examples.
If you go back to 71, there's more to 71 than we did. That's now the greater than less.
Okay. Let me look at 71 then. What did I say the answer was there? I'm just going to hit 3. I'm not going to get through all that again. Okay, there's the multiply both sides by the common denominator. Again, you will get 2x plus 1 is greater than 2x plus 1 is greater than 0, right? And then that's going to be minus 1, square root of 2 times x is greater than minus 1. And then divide by the square root of 2, divide by the square root of 2. So x is going to be greater than -1 over the square root of 2, multiplied by the square root of 2 over the square root of 2, another calculus thing you have to know. X is greater than negative square root of 2 over what? 2. Now, whenever you are dealing, write this down. This is one of those things you need to write down in your notebook and put highlights. Whenever you're dealing with inequalities, the first thing you should do when you find the solution set is what? Graph it. I don't care if you think you know everything. I really don't care because usually you won't. So, graph it. This is negative infinity arrowhead. This is positive infinity arrowhead. They usually want it in two different ways. Set builder notation and an interval notation. So get used to all of it. So where is my answer? What numbers are greater than negative 1.41 over 2? That's negative 1/2, around negative 1/2, right in here, somewhere in here. Do we use a closed circle or open circle? Open, because it doesn't have an equal sign. Now what numbers are greater than negative 2 over square root of 2 over 2? To the right. So you take your handy dandy highlighter and you shade everything to the right, including the arrowhead is called positive infinity. Now, interval notation tells you to read the arrow. So that's going to be from negative square root of 2 over 2 to infinity. And infinity, negative infinity and positive infinity always gets arrowheads. And if you don't touch the number, or you use the open circle, it gets a parenthesis also. So that's interval notation. That should be your answer. Set builder notation would be X. You draw two braces. And you say X such that X is greater than negative square root of 2 over 2. And that should be whatever your answer is. What is square root of 2 over 2? Is that 1.71? 0.71?
Yeah.
I'm looking to see what the answer is. I can't see the answer. Should be negative 1.71 to infinity.
I think it's negative.
Hold on. I don't understand why they have. There's no break. The 1.2, I don't understand where the 1.2 is coming from. We need that chart. That chart, that's what we need, because you can't do inequalities without that chart. Just hold on a minute, I'll find it for you. It's got three things in it, and it says, well, right now I can't even work the freaking board. Hold on. There we go. Let me go to the text. We've got a few minutes, so those of you fixing to have a heart attack, you'll be all right. Pearson e-text. It should be in this section. Hold on a second.
Remember back earlier in the book, they talked about inequalities for very little, and there was something like that.
Let me just Google it, because I ain't got time to look for it. Oh my gosh.
It was a boxed in, yellow boxed in, page 65.
Okay, it might be back way back there.
Yeah, it's in chapter 1.
Okay.
It's 55.
Wait a minute, I've got to get to the right place to. Nope. there. All right. And the reason I have to look it up is because I forget it. Because one, you don't use what page? You don't use it very often. There it is. Thank you. Mr. Haskell, you did good, Harville. All right. Write this down. This is very important because if you don't use it every day, you forget it. And that's the chart right there. As soon as I'll just have to do the problem over. I'm sorry. Write that down and highlight it. You can also, hold on, the next page might be a little bit better. No, yeah. This is on page 55. That's still not what I want, but go ahead and write it down. I'm going to look up something else while y'all are doing that. Let me freeze this. Write that down. Just write down the rules. You ain't going to write down all the words. But before y'all leave, I want to let's see, intersect. Yeah. Well, that's why I try to teach students to always keep the variable positive. And 99% of the time you can do that. With the ones that don't listen to you. Unions and intersections. Okay, I can't find it right now, but I need to find it because you can't make sense out of the inequality problems until you have that chart. And I could try to do it from memory, but I don't want to try to do that because usually it's wrong. It's the union and intersection test for inequalities, and I just have to get in the book to find it. If you have your x on the left-hand side and the number on the right-hand side of the inequality, then you set it up to be x between the positive and the negative. And then it's just I'll have to show it to you. But it's also with absolute values also. So I'll find it and we'll go over that next time. Because we'll run out of time and some of y'all go into cardio infarction, so I need to go ahead and get the roll. Because y'all start fidgeting and start moving around and start standing up and being rude. So yeah, so I need to go ahead and do that.